All right, now we're going to go over lesson 10.11.2, which is how to solve what we call radical equations. So a radical equation is anytime the variable is inside the square root or radical sign. So how do we solve these types of problems? So let's just review really quickly to help us remember some basics. Remember, if I square something, that's that number times itself, so 3 squared would be 9. If I do the square root of a number, that means what number times itself equals that number. So the square root of 9, what times itself equals 9? That will be 3. Now, so you can see the square root undid my square. So for example, the square root of 3 squared, which is 9, is 3. So in the same way, if I have x squared, to just get x, I just do the square root of x squared, and that would be x. So when we're solving radical equations, that is when I have an x inside a square root. What I'm going to do is I'm going to do 4 steps. First step is isolate the radical. So just like we did in previous lessons when we had a variable and we isolated the variable, by doing the opposite, we're going to do the same thing with the radical. So we're going to take whatever is inside the radical and we want to get that by itself. So if there's something being added to the radical, I'm going to subtract that on both sides to get rid of it from that side. If there's something being subtracted, I'm going to add it to both sides. If there's something being multiplied by the radical, I'm going to divide that by both sides. And if there's something being divided by the radical, I'm going to multiply that by both sides. So my goal is to get whatever is inside the radical all by itself on one side, everything else on the other side. Step 2, now that I have the radical all by itself, the opposite of a square root is a square. So I'm going to square both sides. So when I square both sides, that will get rid of the radical. Then I want to isolate my x, so solve for x. After the square root, I've gotten rid of the square root. And then finally, and again, this is extremely important for these type of problems, you have to check these type of problems. Now, other type of problems, it's helpful if you check it, and I recommend it. But you can get most of them right as long as you're doing them correct without checking them. These problems, if you don't check them, you will get some of them wrong, even if you did everything right. So you have to check these. It's not just good to check them, you must check them, or it's a good possibility you will get some of them wrong. So let me show you how this works. So I have the square root of x equals 5. First step, isolate the radical. The radical is already by itself, so I don't need to isolate. Step 2, I want to square both sides. So I'm going to square this side, and I'm going to square this side. So remember, the square and the radical are opposites, so when I square it, all it does is it gets rid of the radical. So now I'm just left with x. It doesn't make x squared, it just gets rid of the radical. 5 squared is 25. I'm done, but I have to check it. Remember, my original problem was the square root of x equals 5, so I'm going to replace x with 25. Is that true? Is it true? Does the square root of 25 equal 5? Yes. So this is my answer. How about this one? Again, isolate the radical first. The radical is already by itself, so I want to square both sides. So remember, when I square this, it doesn't make x squared, it just gets rid of the radical. Those cancel. So I'm left with just x, not x squared. Negative 8 squared is 64. So is that my answer? I have to check. So I check, does the square root of 64 equal negative 8? No, it doesn't. Negative 8 times, the square root of 64 equals positive 8, not negative 8. So what do? Well, my answer is no solution. That is what I have to box in. If you were to box in 64, it would be wrong. Even though you did everything right, it would be wrong. Because this type of problem, it is impossible. There is no answer, because there is no square root of 64 that has a negative answer. So when I check, I see, since this negative is here, the square root of 64 is positive 8, not negative 8. So my answer is no solution. So when you check it, if it doesn't work, as long as you did everything right, then your answer is no solution. That's why you have to check it. Let's look over here. Isolate the radical. Notice this is where the radical ends. So this positive 2 is not inside the radical, so I want to get rid of that first. So I'm adding 2, so I'm going to do the opposite and subtract 2. Now I have the square root of 3x equals 6. Now I've isolated my radical. See how my radical is all by itself on this side? Now I want to square both sides. Again, when you square both sides, that is only going to get rid of the radical. You're not going to square 3 or square x. It's just going to get rid of the radical on the left side. So whatever was inside is now outside. Don't square those. It just gets rid of the radical. Then I have 6 squared. That's 36. 6 squared is 36. So now I have squared both sides. Now finally I want to solve for x. So I isolate my x by dividing both sides by 3. So I get x equals 12. Am I done? No, I have to check it. So back here, for x, I'm going to replace x with 12. So 3 times 12 is 36. The square root of 36 is 6. Does 6 plus 2 equal 8? Yes. So this time, this is the answer. Let's look at the next problem. Right here. So, again, first step is to isolate the radical. Be very careful to see what's inside and what's not inside. Notice all of this is inside, but then the radical stops here, so this is not inside. So what do I want to do? I want to do the opposite. I want to isolate my radical. So positive 6 is being added to my radical, so I want to subtract 6. So now I have 10 plus x equals 1. 10 plus x equals 1. Now I have the square root on the left-hand side. It's all by itself. It is isolated. So what do I want to do next? Well, now I want to square both sides. So I'm going to square this side and square this side. Remember, when I square the left-hand side, all it does is it gets rid of the radical. It doesn't change anything inside. So I still have 10 plus x inside. 1 squared is 1. Now I want to isolate my variable. So 10 is being added to x, so I do negative 10, negative 10. So I get x equals negative 9. Now, I have to check it. So for x, I'm going to plug in negative 9. 10 minus 9 is 1. The square root of 1 is 1. 1 plus 6 does equal 7. So my answer is negative 9. Let's look at this one down here. Last one. So, first step, isolate the radical. The radical is being multiplied by negative 4. Negative 4 is not in the radical, but it's being multiplied, not added or subtracted. So I need to do the opposite of multiplication, which is division. So I'm going to divide by negative 4. That's going to make 1. Divide the same other side by negative 4. So now I have the square root of x equals negative 7. Now I've isolated my radical. I want to square both sides. When I square this side, all it does is it gets rid of the square root. So I'm left with x. When I square this side, I get 49. X is already isolated, so that's my answer. But I have to check. Remember, always check. So square root of 49, x is 49, so I'm going to put that there. Square root of 49 is 7. 7 times negative 4, does that equal 28? No, it doesn't. It equals negative 28. So my answer is not 49. My answer is no solution. So you have to check it because many times it won't work. And if it doesn't work, then your answer has to be no solution. So even if you do this all right and you get this answer, but you don't check it, you can still get it wrong. Because if you check it and it doesn't work, your answer is not this, it's no solution. So make sure for these radical problems, you always check. You must check.